Welcome viewers. In this video we will see the starter used in the three-phase induction motor. First we will see the need for the starter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. The need for the starter. The rotor current at running condition is given by I2R equal to SE2 divided by square root of R2 square plus Sx to the whole square. So the EMF, induced EMF, decide the magnitude of the rotor current, this E2, because this second rotor current is depends upon the induced EMF of the induced EMF in the induction motor. But the induced EMF is depends upon the slip of the motor. The slip is nothing but difference in speed between the synchronous speed and actual speed. So at the instant of starting, the speed of the motor is 0. So the slip is maximum, S equal to 1. Right. So in this equation at the initial, the S equal to 1. So the magnitude of this EMF is maximum. So S become 1. So the magnitude of EMF is maximum at the starting. Therefore, rotor conductor are short circuited. Large EMF circulate the current in the rotor at the time of starting. At the beginning, the slip is 0. So it is purely depends upon the induced EMF. So the magnitude of this induced EMF is maximum at the starting. So the rotor conductor are short circuited and large EMF circulate the large current in the rotor at the time of starting. In induction motor, when the rotor current is high, the stator draws a very high current. So it is about 5 to 8 times of full load current. So due to this inrush of high current, it may damage the motor winding and large line of voltage drop. So the limit this high starting current, the stator is used. So the purpose of starter is to limit the high starting current. So that a starter is a device which is used to limit the high starting current by supplying the reduced voltage to the motor at the time of starting. So the starter is nothing but a device that is limit the starting current. How it is limiting? By supplying the reduced voltage. We need to reduce the voltage applied to the motor so that automatically current taken by the motor also reduced. And this starter provide the protection to the induction motor against overloading or low voltage. It is also used as a protective device from the overloading or low voltage. Now we will see the types of starter. The first type is stator resistance starter, auto transformer starter, star delta starter, rotor resistance starter, direct online starter. There are 5 types of starter available. In this video, we will see the stator resistance starter. Remaining 4 types available in a separate video. Now we will go to the stator resistance starter. So the 3 resistance are added in series with the each phase of the stator winding. So the stator resistance method means the 3 set of resistors are connected to the each phase of the stator winding. I will refer the diagram. So this is a 3-phase induction motor. This is stator, this one rotor. This 3-phase induction motor is connected through the resistance, 3 set of resistance. So this is the maximum resistance portion. That is, the voltage is fully dropped and the remaining voltage will be applied to the stator. If it is placed at the beginning, it is a minimum resistance portion. The full voltage will be applied. So initially it is at the maximum resistance position and it is connected to the 3-phase AC supply through the switch. The stator is connected through the 3-phase AC supply by the switch and in series with the 3 set of resistance. So at the starting position, during the starting, the resistors are the resistor is placed at the maximum resistance position, so that the voltage will be dropped across this resistor, only minimum voltage will be applied to the stator. So due to the minimum voltage, the current taken by the stator also reduced. So after that, this resistance is gradually decreased by moving the position from this point to this side, moving in this by slowly reducing the resistance, that is moving from this point to this point, that is here clearly given starting position. So moving from starting to running position, the resistor is gradually decreased, so that voltage applied to the stator is gradually increases, and also current taken by the stator also gradually increases. So finally the full voltage will be applied, full rated voltage and full rated current will be taken by the stator. So initially the resistor is added, so the voltage applied to the stator is limited in order to limit the high starting current. Thereafter the resistor is slowly decreased and the voltage is applied gradually increases, so that current taken by the motor also increases. I will see the description. Initially the resistors are kept at the maximum position. Maximum position means maximum resistance. Large voltage get dropped across the resistance. So the voltage will be mostly dropped across resistor. So the reduced voltage is applied to the stator. Only the reduced voltage is applied, so that starting current also reduced. Right? Because of reduced voltage, the starting current also reduced. That is our main objective. When the motor starts running, the stator, the resistance are gradually cut off. The resistance are gradually reduced. When the resistance are entirely removed, the motor runs at the normal speed. So initially resistors are added, so that reduced voltage is applied, so the reduced current also taken by the stator. Thereafter resistor is gradually decreased, so the rated voltage will be applied and rated current will be taken, and the motor starts rotate at the normal speed. Now we'll see the what are the disadvantages and disadvantages of this stator resistance method. The advantages are just simple construction. Only we need a 3 set of resistors, and the cheap. The cost is also very cheap, because only we need one set of resistor. Can be used for both slip ring as well as screw gauge type of induction motor. It is applicable for both the type of induction motors. But what are the disadvantages? The large power is lost due to the resistor. Right? The power is lost because initially we are using the maximum resistance position. The entire voltage will be dropped across the resistor, so the more power loss will occur in the resistor. So due to this full voltage is dropped across resistor, the starting torque is reduced only because we are applying only reduced voltage. So the starting torque is reduced due to the reduced voltage applied to the stator. The torque also reduced. So in this video we discuss about the starter used for 3-phase induction motor, need for the starter, why we are using the starter. Then there are 5 types of available in this. The first type is discussed in this video, stator resistance method. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the 3-phase induction motor auto transformer starter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic, auto transformer starter. So the main purpose of starter used in the induction motor is to limit the starting current taken by the stator. In order to limit the starting current, we can apply the reduced voltage to the stator. So by reducing the voltage applied to the stator, automatically we can reduce the current taken by the stator. So the reduced voltage is given by using the auto transformer. So our main objective is to give the reduced voltage to the stator in order to reduce the high starting current. So a 3-phase star connected auto transformer can be used to reduce the voltage applied to the stator. So we are using the 3-phase star connected auto transformer to reduce the voltage applied to the stator, so that we can reduce the current taken by the stator also. I will go to the diagram. So this is a 3-phase induction motor is available. It's a stator. This one rotor is available. Here we are having the star connected auto transformer. Here we are available with this changeover switch is available. changeover switch, one side is connected to the auto transformer, another side connected to this run position. This where it is auto transformer is called a start position, is a run position. Run position is nothing but a simply a short circuit. The entire voltage is applied. So this is the three-phase AC supply. So we have three-phase induction motor. Stator is connected to the three-phase supply through the changeover switch. This is a rotor. Auto transformer, star connected auto transformer is available at one end, another end is short circuited. This end is called a starting position, this one is running position. So initially the changeover switch is placed in the starting position, that is through the auto transformer. Initially only less voltage is applied to the three-phase induction motor using the auto transformer. So the only the reduced voltage will be applied to the stator through this. See the position here, only few voltage, only the least amount of voltage will be applied to the stator. After that, after some time, and when the speed of the induction motor gradually increases, the voltage is gradually increased by using the auto transformer. By using the auto transformer, the voltage applied to the stator is gradually increases, so that the motor will start at the rated speed. Once it is started with the rated speed, the changeover switch is placed in the running position. So during running position, the entire voltage is applied. So the motor will rotate at the rated speed by taking the rated current and rated voltage. So this auto transformer initially used to reduce the voltage applied to the stator, so that we can reduce the high starting current. Thereby slowly, by changing the position, we can apply the voltage applied to the stator, we can slowly increases. Thereby finally it will take the full rated current and full rated voltage and rotate at the rated speed. Thereby it is the changeover switch is placed in the running position. Now we'll see the description. So it has a changeover switch. The changeover switch is available. When switch is at start position, the stator winding is supplied with the reduced voltage, which is controlled by the tapping provided with the auto transformer. So the changeover switch is available. If the changeover switch is placed at the starting position, it will reduce the voltage is applied by means of tapping provided in the auto transformer. When the motor gather 80% of normal speed, the changeover switch is thrown into run position. Run position means the entire voltage will be applied. Now the rated voltage is applied to the stator winding. The motor rotates with the normal speed. The change of switch is done by the relay. By using the relay, the change of switch is done. Right. So in this method, auto transformer is used to apply the reduced voltage to the stator, so that the current taken by the stator also reduced. The main advantage of this method is power loss is less. In one more method, stator resistance method is available. In that the power will be lost, but here power is not lost. But another disadvantage is expensive. If it is the stator resistance method, it is a very cheapest method. Only one set of resistor needed. But here we need a auto transformer, so that is more expensive. So in this video we discuss about the three-phase induction motor starter based on the auto transformer starter type. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the three-phase induction motor star delta starter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic star delta starter. In order to start the motor, we are using the one type of the starter is star delta starter. The stator winding, during the starting it is connected with the star connection. During the running it is connected with the delta connection. So this is the method used in the star delta connection. This is most commonly used for induction motor. Normally used starter is the star delta starter. Now we will see refer the diagram. So this is the stator winding is available. So stator winding, right? One dash one phase, 2 2 dash another phase, 3 3 dash third phase. So here the 3 phase AC supply is available. So here the changeover switch is available, TPST switch is available here. So this one side it is connected with the star connection. If you connect the switch in this bottom end, it is the stator winding is connected with the star connection, that is 1 dash, 2 dash and 3 dash are connected. If the switch is connected in the upper end, then it is a delta connection, that is the winding, the portion 1, 2, 3 are connected, right. So during the starting, the TPST switch is placed in the star connection. That is clearly given, starting it is connected star connection. Why we are connecting star connection? In the star connection, the current, the voltage is reduced by the factor 1 by root 3. In case the nature of the star connection is only 1 by root 3 of voltage will be applied to the stator winding. So due to this reduced voltage, the current drawn by the stator also reduces. Once the induction motor gain the normal speed, the switch is changed over to the running condition, that is a delta connection. The switch is changed from the TPST switch is changed from bottom to the top, so that the induction motor stator winding is connected with the delta connection. So during delta connection, it will drawn the full voltage, root 3 times of voltage, so that the rated voltage will be applied to the stator winding, so that the current drawn by also gradually increases and motor will run at the normal speed. So the main aim is, during starting, the stator winding is connected with the star connection in order to reduce the voltage 1 by root 3. Once the motor gain the normal speed, normal voltage, the connection is changed to the upper end of the TPST switch, so that it is connected with the delta connection. Now we'll see the description. It has the triple pole double thrown switch. TPST switch is available. TPDT, triple pole double thrown. The TPDT switch connects the stator winding in star at the time of starting. So at the time of starting, we connected with the star connection. Why it is connected star connection? The phase voltages get reduced by the factor 1 by root 3. The nature of the star connection is the voltage is 1 by root 3 times. The current will be same, but the voltage will be 1 by root 3 times. So due to this reduced voltage is given to the stator, and the starting current is limited, because the voltage applied is only 1 by root 3 because of star connection. Due to the reduced voltage given to the stator, the starting current also limited. That is our main aim. Main aim of the starter is to limit the starting current. After the motor gains the normal speed, the switch is thrown into the other side, that is delta. So the starter gets the rated voltage. So the initially it is given in star connection, it will take only 1 by root 3 of voltage, so that the starting current is limited. After gaining the normal speed, the switch is thrown into another side, is a delta connection. During this delta connection, it will get the rated voltage. The relays can be used for operation of the switch. The changing the switch from star connection to delta connection can be done by the relays. Now we'll see the advantages and disadvantages of this method. The advantage is cheapest of all type of starter. Only we have one switch is there. We are connecting in star connection, thereafter delta connection. No more additional equipments are needed, so that it is the cheapest method. Maintenance free operation. There is no other parameters are the equipments are available. Only the changeover switch is there. So the maintenance also free operation, maintenance free operation, cheapest as well as maintenance free operation. What are the disadvantages? Used only for normal delta connection motor. If the stator winding is connected in delta, then only we can use this starter, because the stator winding is initially connected with the star, finally it is connected with the delta. So we need a delta connected motor, then only we can use this motor. Delta connected motor is needed. And factor by which the voltage is changed to 1 by root 3. At the beginning, we are applying only 1 by root 3 of time of voltage, but it cannot be varied. Always it is 1 by root 3. We cannot change it with the lower value or higher value. We cannot vary this. Always it is 1 by root 3 times of the rated voltage. So these are all the disadvantages. So in this video we discuss about the star delta starter 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the 3-phase induction motor rotor resistance starter. There are 5 types of starter available. In this video we will see the rotor resistance starter used in the 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. So here we are using the rotor resistance. The resistance is added in the rotor circuit. Here a resistance is inserted in each winding of the rotor. So this will reduce the current drawn by the motor. Right. So by adding the resistance, the current drawn by the motor is reduced. That is our main objective. During the starting, we need to reduce the starting current by the induction motor, so that we are using this starter. So in this diagram, we will refer the diagram. So the stator winding is available. This is the rotor winding. It is slip ring induction motor. So it is connected with the external resistance. This external resistance are connected. So it is connected with the maximum resistance portion. So this point is the maximum. If it is connected here, it is the entire voltage is applied. While connecting here, the voltage will be dropped here in the resistor, and the remaining voltage will be given to the slip ring. So the maximum resistance position is connected at the initially. So the current drawn and voltage applied to the rotor winding is reduced. If the voltage applied to the rotor winding is reduced, means automatically voltage taken by the stator winding also reduces. Right. So while reducing the rotor voltage, automatically stator voltage also reduces. So where the voltage is reduced, the current drawn by the stator also reduces. That is our main objective. During the starting, the current drawn by the stator should be limited in order to avoid the damage. So in order to limit the current, we are applying here the stator takes, if the stator takes the less voltage is applied, automatically the current taken by the stator is less. In order to make the stator voltage lesser, we are making the rotor voltage is lesser by inserting the resistance. So due to the resistor, the voltage taken by the rotor is less. Due to less voltage in the rotor, the voltage in the stator also less, so that it will draw the less amount of current. Once the motor is gained the normal speed, then the resistance is gradually decreased and apply the rated voltage, so that the motor will take the rated voltage and it will rotate at the rated speed. I will see the description. The resistance are connected in the star, in a star connected. These resistors are connected in a star connected manner. External resistor is inserted in each phase through a slip ring and a brush assembly. Right? The external resistor is connected. Initially the resistor are at the maximum position, maximum resistance position, so that voltage is lesser. So due to that, stator voltage is lesser, stator current drawn also lesser. Right? So as the motor gathers the speed, the resistance is gradually cut off. Automatically it will, while reducing the resistor gradually, the motor will gather the normal voltage and it will gather the normal speed. Now we will see the advantage and disadvantages. So the main advantage is torque is directly proportional to the resistor, external resistor. Initially the resistor is very high, so that automatically we are getting the more torque. R2 is highest during the starting, so that torque is very high at the starting. Right? Due to the high resistance added at the beginning, we are getting the highest torque at the beginning. The disadvantage is it can be used only for slip ring rotor. In a screw gauge rotor is one more type available, where we cannot connect any resistor to the screw gauge rotor. Only in the slip ring rotor only we can use this method, because in the slip ring we can able to connect the external resistor, but in screw gauge there is no connection. we cannot add any external resistance. So in this video we discuss about the rotor resistance starter used for the 3-phase induction motor, working principle, advantages and disadvantages. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the 3-phase induction motor direct online starter, DOL starter. There are 5 types of starter available and one type is direct online starter. In this video we will see the working principle of direct online starter. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic. So in a low capacity motor, that is less than 5 horsepower, the starting current is not high. So the main objective of starter is to reduce the starting current taken by the 3-phase induction motor. In order to avoid the damage, we need to limit the starting current. But in case of low capacity motor for this 5 horsepower, less than 5 horsepower, the starting current is not very high. It is already it is lesser. So they can withstand the starting current without any starter. So in case of low capacity motor, without the starter, we can start the motor because the starting current is lesser. So there is no need to reduce the voltage to control the starting current. Right? To reduce the starting current, the starter will reduce the voltage applied to the starter. When the voltage reduces, automatically the starting current also reduces. So here the low horsepower motor, no need to reduce the voltage. So they use a starter which connects the stator directly to the supply. So in this type, the supply is directly connected. No need to reduce the voltage. Our aim is to reduce the current. We need to reduce the voltage in this, but it's not needed. Without reducing the voltage, hence it is called as a direct online starter. So due to this objective, due to this low capacity motor, the supply is directly given to the motor without any reduction. So that it is called a direct online starter. But though it does not reduce the voltage, it will protect the motor from the overloading and low voltage. The other advantage of this method is either we are connecting directly, but there is a facility available is we can protect the motor from overloading and low voltage. Now we will see the diagram. By referring the diagram, so the stator is available, stator winding, the slip ring is there. There is a 3-phase AC supply is available. So this is a fuse. For protection purpose, fuse is there. Then thermal overload relay is available. During overload or during overcurrent, then more current will be drawn. At the time, this thermal overload relay will be cut off. In order to protect the overloading, we are using the thermal overload. So it is available. Here one the energizing coil is available. Magnetizing coil is available. Here we have 2 contactors available. NO means normally open. It is normally in open condition. Here NC normally closed condition, always in closed condition. Right? So due to this normally open, the supply is not given to the magnetizing coil. It is in a open circuit manner. Right? So in order to start the motor, we are pressing this normally open contact. This normally open contact is closed. So that what will happen? The supply is given to the magnetizing coil. So this magnetizing coil, due to the voltage applied to the magnetizing coil, it is energized. So it will attract this contactor. This contactor is attracted so that the supply is directly given to the stator. So initially, yes, NO is in open condition, NC in closed condition. Due to the open condition, the supply is not given to this magnetizing coil. It is in a de-energized manner. So in order to start the motor, this NO is closed. So while closing, the circuit is closed. The supply is given to the magnetizing coil. Due to that, it become energized. Due to the energized, it attract this slip ring and the supply is connected to the stator. Now the motor is applied with the rated voltage. Suppose if any abnormal condition is there, we want to disconnect the supply, this NC is open. If you open the NC, what will happen? This magnetizing coil is, the supply is not given to the magnetizing coil. the supply given to the magnetizing coil is cut off, so that it is de-energized, and so that it will release the slip ring, so the supply is disconnected during abnormal condition. And another facility available is overload or overcurrent. Suppose in a normal operation, if any overload or over current is taken, means this thermal relay will be cut off, so that it will disconnect the motor from the supply, right. So I will explain again. So the 3-phase AC supply is available, fuse is there for protection purpose, thermal overload relay available for to protect the overcurrent. This is the stator available, is connected through the slip ring. One energized magnetizing coil is available. This contactor is always in closed condition, this contactor is always in open condition. So that during the starting, this NO is closed, so the coil is energized, it will attract the contact, so the 3-phase supply is given to the stator winding. So the motor will start at the rated speed. If we want to stop the motor, we can open this NC. This contactor NC is open, so the supply given to the magnetizing coil is disconnected, so it becomes de-energized, and so that the supply is disconnected from the motor is disconnected from the supply. If the motor goes for any overload or overcurrent, the more current is taken by the motor, the temperature increases. Due to that, the thermal overload relay will cut the supply to the stator winding, so that it will protect from the overload or overcurrent. Now we'll see the description. Normally open, NC means normally open, NO means NC means normally closed. So at the start, NO is closed for a fraction of second, due to which coil is energized and attract the contactor, and so the stator is directly given supply, right. When NO is closed for a fraction of second, coil is energized and it will attract the contactor, so that the stator is given to the supply. The supply is given directly to the stator. The additional contact ensure that as long as the supply is on, coil gets the supply and keep the contactor in the on position. So the supply is given through the magnetizing coil, so it is always in energized condition, so keep the motor in on condition. Suppose if you want to disconnect, then when NC is pressed, normally closed, the coil circuit gets open. While pressing the NC, the circuit is disconnected, the coil is disconnected, so due to this the coil get de-energized, so the motor gets switched off from the supply. Due to de-energize, the attraction will gone, so the contactor will disconnect the supply. So this is another method. If you want to disconnect the supply from the motor, we can press the NC. Apart from that, an overload, the current during the overload, the current drawn by the motor increases, so the heat is produced, so which increases the temperature beyond the limit. So during the overload, more current will be drawn by the motor, so due to that heat is produced. So the thermal relay is available, thermal relay get open due to the high temperature, so protect the motor from the overload condition, right. So during overload, we are using the thermal relay to disconnect the motor from the supply. So in this video, we discuss about the direct online starter used in the 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.